it's a fact that there is a gap between the security industry from one side and the software development industry from the other side. The software developer folks are interested in, are driven by deadlines, by timelines, by budget, and by business requirements. On the other hand, security is mostly driven by risks, attacks, threats, writing secure code, things like that. So there is a gap between the two industries. Hopefully today we'll try to bridge this gap by introducing a simplified security code review process. Hi, my name is Sherif, and thanks to Austin, I started OWASP back in 2006, worked with SANS starting 2008, started Software Secure 2009, and helping Web Application Security Consortium, a nonprofit organization, define static code analysis criteria to help software organizations who are trying to acquire software static code analysis tools, help them pick the right tool for their environment. By the end of this session, you'll be able to identify what are the important aspects of a security code review process. And you'll be able to understand how a simplified security code review process looks like. How can you start that in your software development team if you don't have already one? Software security code review process can be intimidating, but hopefully by the end of this session, you'd be able to kick off your internal process. So why security code review process? Security code review process is known to be best at systematic approach to uncover security flaws. What does that mean? Other assessment methodologies to try to provide security assessments for applications depend a lot on the skills of the person doing the assessment, depends a lot on the tools being used, depends a lot on the time given, like for example, web application penetration testing. However, I'd like to believe that security code review process is a deterministic way of finding, of uncovering security flaws systematically. If you apply the same process over software, you get the same results. And this is what we care about in business. So I'd like to believe that security code review process is a way to take the magic out of finding security flaws and make it more like a process that can uncover security flaws systematically. Security code review is also good at covering close to 100% of the source code. We can argue whether it does actually get to 100% code coverage, or do we even need 100% code coverage, right? But we can agree that we need to cover as much of the application, we need to test as much of the application as possible, and security code review is best at doing that. Better at finding design flaws than other assessment methodologies, other testing methodologies. And why is that? Because we have an aerial view of the application. You're looking from above at the application. So you're not constrained by a UI, you're not constrained by what the application is serving you because you don't care. You're looking at the source code itself. And this is my favorite. It finds all the instances of a certain vulnerability. So for example, if you found a cross-site scripting issue, for example, it would be really easy to like write a script that would look for that particular cross-site scripting pattern in the source code and find all the similar cross-site scripting issues, right? Versus, for example, web application penetration testing or other ways of testing applications where if you found one, you might not be able to find all the rest of the instances of the same vulnerability easily. And it's the only way to find certain types of vulnerabilities, like application logic bypass, like certain types of SQL injections, like certain types of cross-site scripting. This is only because we actually see the code. So, if security code reviews are that good, why everybody why not the software development, why the software development industry is not using such a great process. I like to believe that it's a perception issue. Let me explain. So I like to go to the gym, right? Not because I like to go to the gym, I don't like the pain, but I like to be healthy and fit. But I feel intimidated by all those, you know, when you go to the gym, all those healthy people running on their treadmills. So I like to believe that I'm fit and healthy as much as they are. So I think of myself as like this guy, for example, Usain Bolt. Just because of the oh, okay. So I like to believe that I'm running like this guy, Usain Bolt, just for the spirits of the Olympics. Anybody here from London, England? Woohoo! Right? So this is how I like to think that I look at the gym, right? Of course, until my wife reminds me of how I actually look at the gym, right? Anyways, the goal is, I like to believe that the software industry perceives security code reviews and security in general as this very hard thing to do that we don't have time for. And hopefully by the end of this session, I'd like to prove the opposite. Maybe it is, I thought it's a perception issue. I also think that the software industry thinks of attacks and cyber war and data breaches as that thing that happened to the guy next door. It's not going to happen to us. It never did before. It just happens to the guy next door, to the companies that get breached over and over again. And this reminds me of, interesting. So this was supposed to be a photo from Lord of the Rings movie, The Two Towers. Anybody familiar with this movie? So you probably cannot see it, but what this shows is that the 10,000 orcas descending on Helm's Deep and sitting ready to attack the city. This is what this picture is supposed to show. The king believed that he knew that there is a huge threat out there. He understands the threat quite well. He didn't react enough to that threat, and he thought, since I have my wall, I'm okay. As long as I have my wall, I'm okay. And this is how the software industry thinks of their applications. As long as they have firewalls and as long as they have all those tools, they are okay. Until one ugly-looking Oracle finds a small wall finds a small hole in the wall, and then shit hits the fan, right? So, what do we do in order to prevent attackers from finding those small holes in the application walls? So security code review is a process that looks for software weaknesses, things like SQL injections, things like cross-site scripting, cross-site request forgery, insecure authentication, authorization, all those software weaknesses. It looks for application logic issues, as we said, dead and debug code. Dead and debug code are usually things, are places in the application that are not well attended to. A developer might have started working on a feature, requirements changed, the feature made the code, he already submitted it to SVN, deployment manager took everything in SVN, put it on production, and there you go, an unfinished feature on production that doesn't have the same security controls, same validation, same things as production code. Misconfiguration issues for obvious reasons. So, what constitutes a successful security code review? Two things: security code review mindset and a good security code review process. Security code review mindset and a good security code review process. So what does a security code review mindset looks like? If you're reading code before, your concerns are probably two things. the code compiles and the code runs, right? That's it. Next. If you are reviewing code, like just regular peer code review, you have a slightly different mindset. You know that the code already compiles and runs, hopefully, but you would be thinking when you see each line, how can this line blow up the whole application? How can this line be written more effectively, right? Security code review is slightly different. So in order to put yourself in a security code review mindset, you need to ask yourself 3 questions while you're doing security code review. Where is this data coming from? And do I trust this data? And we are going to look at a part of the process that answers this question systematically. Can the original intent of this line be changed to a malicious intent based on the answer of the first question? And whether there is any mitigating control. Has this data been validated? Are there any like natural mitigating controls? Like, for example, you have a SQL query that is constructing the SQL dynamically using unvalidated data, but then the data is casted to an integer. Now it's not exploitable. So this is kind of like, it acts as a mitigating control. It still needs to be fixed, but it's not exploitable in this case. So those are the 3 questions that would help put you in a security code review mindset. So important aspects in any process. So what does a full security code review process looks like? You got to do a reconnaissance, like understand the app. What's the business goal of the app? What are the use of the app? What are the kind of users the application is trying to serve? What are the use cases for the application, etc. Next, threat modeling, just a mini threat modeling process on the application to understand what kind of threats does this application will face. Is there any compliance regulation the application falls under, etc. And then we start with automation to get all the low-hanging fruits and kind of like the hot spots in the application where we should look closely. This is followed by manual review for high-risk modules, things like authentication modules, authorization, file uploads, downloads, encryption, all the high-risk modules. And then confirmation and proof of concept, which is mainly weed out the false positives from the automation process, which tends to produce a lot of false positives. And confirm high-risk vulnerabilities. You might find a SQL injection that's buried like 10, 15 calls. So we got to see what's the exploitability of that SQL injection. And then finally, communicating back those results to the developers so that they can easily fix those vulnerabilities and go back to their regular deadlines. So this is what a full application security code review looks like. At the center of that lies security skills, tools mainly used in automation, and a bunch of checklists just to make sure that you covered all your grounds. That doesn't look very simplified, does it? This is not what we're discussing today. We are discussing today a whole lot simpler approach towards security code reviews. So there are only 4 steps in this simplified security code review. Trust boundary identification, automation, manual review, and reporting. And at the center of that lies OWASP Top 10. So a simplified code review relies mostly on OWASP Top 10 as the vulnerabilities you actually need your developers to look at in a simplified software development security code review process. Checklists, you can grab a bunch of those from OWASP cheat sheet series. If you attended Jim's talk just before that, this is a great project. Very concise cheat sheets, very like to the point, and you can use them to do your own checklists. So trust boundary, defining trust boundary. Trust boundary is that this virtual line that where the trust level changes. Trust level changes like things like privileges change. So an anonymous user, for example, becomes authenticated as a regular user. A regular user elevates his re-login or something and becomes an admin. So every time privileges changes. Untrusted data received, untrusted data sent. All these are examples of where trust level changes. So this is a diagram from the famous book of Writing Secure Code by Michael Howard, and it depicts how does it look like on paper. So mainly the trust level is this virtual line that encapsulates those two guys trust each other. So when they send data to each other, they don't need to validate each other's data because they are in the same level of trust. Anything outside that trust boundary needs to be validated when it sends data. So we put checkpoints here. So this is the original intent from trust boundary identification. We are using it a little bit differently. We are using it to find the code that deals with this place. We're using it to identify which code should we look at a little bit more closely. And why is that? Because the trust level changes. When the trust level changes, this is a place where you want to look at the code and make sure that everything is going all right. So take, for example, take this as an example. So this is your typical web application. We have a front controller that has the business objects in another layer that talks to the data store using a data access layer. There's a bunch of web services serving some SOAP clients, and there's a different admin application that talks to an admin client that can actually can only access the admin front controller through the LAN, cannot access it from outside. And there's an ad server here that we pull some ads from every now and then, right? Just a typical web application architecture. So you might be thinking that, oh, everything inside the LAN is trusted. But when you look closely, all right, do we trust the database? Do we trust the LDAP? Do we trust the file system? How can we trust them when these databases and file systems are already fed from the user? The user uploaded their files, so they are full of untrusted data to start. So on a second look, we might think, okay, we're not going to trust these guys here, database, LDAP, file system. But when we look closely, do we trust the LAN? Do we trust the internal LAN? Is the LAN under our control? Do we trust this guy, whoever is using the admin client? So it might be a little bit safer to define the trust boundary as all these guys. And then we need to put validation every time the trust level changes. The trust level changes when there is a privilege change, untrusted data received, untrusted data sent. So things like these guys, these blue circles here, this is where data is received and sent. So these places needs to have like validation controls. But we're not putting validation controls, we're identifying code that is dealing with trust boundary violation issues. And when we cross the trust boundary, this is when data is received, data is sent, so this is the places we need to look at. So it looks good on a paper, but I get a patch, I'm a developer, I get a patch. How do I know that this is inside the trust boundary or outside the trust boundary? So these are suggested ways to look at, to make it easier for developers to get an idea of whether I need to look at this code closely or not. For example, I apologize for the screen, physical source code separation. So it might be worth it to separate the code that is inside the trust boundary into different source code, into different physical file system, different folders at least, and the source code outside the trust boundary be on another. So the developer would know just from the path of the file that he is actually looking at. Another way may be to a naming scheme. A naming scheme. Trust boundary safe, so for example, name it TBS for trust boundary safe. If it's trust boundary unsafe, name it differently, TBU, for example. Just an example to understand, to have a guide on whether I should be looking at this code or not, whether I should be looking closely at this code or not, whether this code is dealing with untrusted data or not. Next, automation. So the first step is trust boundary identification. Second step is automation. So automation comes in many flavors. So for example, the super greps, which is basically looking for keywords that are problematic, like for example, out.print, like for example, request.getParameter, like for example, SQL adapter. All these keywords that you would know that there is something that you need to look at this point. Automated unit tests, it might become a little bit overwhelming to write a separate unit test, especially if you don't know what you're looking for. Most probably, we're going to use some form of static code analysis tools. So static code analysis tools is not security code review. Static code analysis tools is a very good, it serves the automation part very well. Why? Because it scales well. If you have a portfolio of a bunch of applications, then it might be good to have something that grabs all the low-hanging fruit. It can be taught new tricks. It can be modified and altered to learn about your environment and your frameworks and your controls and your modules. They can be taught, so it can get better. Cons, they're full of false positives. They miss application logic issues, and they have a problem with frameworks and collection. You just stumble when they see a collection, like a list, like an array. If you have a struts application, these are the areas where they don't perform as well. So there are a bunch of open source free tools at your disposal. All these tools are free to use. For Java, you got FindBugs, PMD, Yaska, stands for Yet Another Source Code Analyzer. Funny name. .NET, you got FXCOP, C++, the good old famous PC-lint. So I'm just going to do a quick demo on how you can do your own static code analysis using one of those open source tools to look for dangerous patterns in the code. So I have here three very simple rules, like something to look for SQL injection, something to look for cross-site scripting, and something to look for forwards and insecure forwards and redirections. So all what I just did a very simple example that looks for select anything from. Just to make the point that you can do your own patterns and look in your own code for the things that you think might be dangerous. GDS as well has a bunch of rules like these free to use on GitHub. So just go to GitHub and look for GDS PMD. GDS PMD. Those are just very simple rules. You might find the other rules a little bit better. So just to prove the point, I'm going to go here and I'm just going to clear the previously found results. I'm going to scan again using PMD. PMD comes in a plugin. PMD comes in a plugin, so you can easily add it to Eclipse or you can easily add it to NetBeans. Then I'm going to check the code. I already built my 3 rules here and added them to PMD because the default PMD does not come with any security rules. You got to do your own. The rules that I mentioned is a very good place to start, or you can do your own. here it shows an error, and this error is actually our security code review, our rules. So for example, if I look at login, for example, a SQL injection detected, because I'm looking for select anything like dot asterisk, regular expression, from. So it actually happens that this is a UID. I try to trace this UID back, and it looks like it's coming from an attribute, and you would be able to find whether this is something that you should fix or not. Hopefully all SQL statements should be done in changed to prepared SQL statements, but this is a way to give you where are the places to look inside the code. This is, for example, a cross-site scripting and an insecure redirection forward as well. So this is just an example of how you can do your own automation using open source tools. Just gonna get going here just because of the time. So you can use the same techniques to find bugs like SQL injection, cross-site scripting, parameter tampering, all these vulnerabilities. It might take you a little bit of time at the beginning. The rules I mentioned is a very good place to start, and then you can start doing your own. The most important point about this tool is that they have to be customized, whether you start with the open source ones or whether you went the route of commercial tools. You can get a lot more mileage from these tools if you are able to customize them to your own needs and make them understand your application a little bit better. Now, manual review. Okay, if the tools can find all those issues, why do we need manual review? All those issues that I mentioned are pattern-based vulnerabilities. You can find them through a pattern. If they can find them through a pattern or through a data flow, then it's easy for the tool to use. But if the vulnerability is a logic-based vulnerability, then it becomes very, very hard for a tool or a script to find. So application logic bypass issues, for example. Logic, the tool cannot understand logic. It needs a human to look at the source code. So let me give you an example. These are the areas that need to be reviewed manually. Things like authentication and authorization controls, file upload and download, encryption modules, validation controls, input filters, security sensitive application logic issues, processes. So let me give you an example. This is a piece of code from like a regular page. So the page, here's the page load, and it checks if the user is not in this role, do not serve the page. But there is a web method here. So the problem here is this web method can be easily called from Ajax. And because web methods do not follow regular ASP.NET lifecycle, so this code here is not going to be called at all. Only a human can find this type of issue. Take another example, an encryption flaw. So this is SHA-encrypt. The application is using it to hash passwords in the database. So the tool or the script might find that, oh, you're using SHA-1. Do you really trust SHA-1? It might figure out that we're not using assault. But the elephant in the room is it's a typical fail open scenario. Only a human can actually find it. If any problem happened here, guess what the application will return? An empty string. And nobody will know because it is catching the exception, logging it, and if somebody looked at the logs, maybe, right? This is actually an example that was found during a code review that would have made it to production unless somebody actually looked at the source code. File upload and download flaws. So take this for example. There is a page that submits a file to another page. The second page takes the name of the file, validate it, create a temporary file on the file system, put the contents of the uploaded file in the temporary file on the file system, takes the path of the temporary file, put it in a hidden field, and then on the post back, it uploads the file. Now, what's the problem there? The problem is, there are two problems actually. The first problem is that in the hidden field, there will be the structure of the file system, so this is information leakage. On the second path, the application did not validate it on the second time. So an attacker might have actually played with the path of the file and uploaded a different file from the server's file system. So these are just examples of places or scenarios that a human is actually needed to look at the source code. So manual review is important, and these are the places that you need to look at: authentication, authorization controls, encryption modules, file upload and download operation, validation controls, whether they are performing correctly or not. We've seen a lot of examples where input validations is done mostly based on blacklisting, and there's always holes in it, so you have to look at it. Security sensitive application logic, whether it can be influenced to do something different, to do something malicious for the attacker. And finally, reporting. So reporting is not just creating a bug. Reporting is communicating what is the problem and what is the impact of the problem. All the regular QA bugs will not perform the functional requirements that the bug exists because it's going to crash the program, the application, or maybe because it's not going to do what the application is intended to do, or it's not the best way to do the thing. These are mostly what all the bugs are. So all of them needs to be fixed. But here there is a business impact. So you need to provide what is the business impact plus in the bug. So for example, you need to provide what is the weakness metadata. Like how can the developer find it, where to find it, where exactly does the problem happen. And a thorough description. What is the problem? It's building dynamic SQL statement using unvalidated data. And what is the unvalidated data? Here, its name. Oh, I'm sorry. SSN.text. And a recommendation, good recommendation. And you might even point them to where to look for a fix, because in a regular code review, you don't need to do that because the developer understands the code and most probably 99% will understand how to fix it. But when security is in there, you want to point them to where to look to find fixes. Again, the cheat sheet series is a very good place to look. And assign appropriate priority so that the developer can actually prioritize like his to-do list. So that was the simplified application security code review process, identifying trust boundary, just to understand what is the code that we actually need to look at, automation to cover everything else, manual review for the important security sensitive places in the code, and reporting so that all these steps make sense. The whole process is based on OWASP top 10, checklists, and you can grab checklists from the the cheat sheet series. The tools, static code analysis tools, there are free tools out there. We've talked about that. And there are commercial tools. Visit the static code page on WASP Web Application Security Consortium to find if you want to purchase static code analysis tools. I don't sell any. I'm just helping out WASP identifying a criteria for static code analysis tools. So this is like a piece of code that hashes any string. It was used to hash passwords. So the exception management here is problematic. Why? Because if an exception happened here, it doesn't really matter the point behind this source code is not the source code itself, it's the exception management part of it. So if anything happened here and went wrong, this piece is going to be called, right? Next, it's going to return sp.string, .toString. The problem is, let's say that the problem happened here, right? So the string buffer is empty, so it's going to return an empty hash, and nobody's going to know. But like I guess my point was, if you look at this at the first glance, oh, am I using the right hashing algorithm? Am I using SALT, the regular security code review guidelines? But when a human looks at it, he would start looking at, oh, this is not right. Something wrong is going to happen here, and it's going to affect the security of the application. So, yeah. Any other question? All right, if there's no other questions, then thank you guys. It's a fact that there is a gap between the security industry from one side and the software development industry from the other side. The software developer folks are driven by deadlines, by timelines, by budget, and by business requirements. On the other hand, security is mostly driven by risks, attacks, threats, writing secure code, things like that. So there is a gap between the two industries. Hopefully today we'll try to bridge this gap by introducing a simplified security code review process. Hi, my name is Sherif, and thanks to Austin, I started OWASP back in 2006, worked with SANS starting 2008, started Software Secure 2009, and helping Web Application Security Consortium, a nonprofit organization, define static code analysis criteria to help software organizations who are trying to acquire software static code analysis tools, help them pick the right tool for their environment. By the end of this session, you'll be able to identify what are the important aspects of a security code review process. And you'll be able to understand how a simplified security code review process looks like. How can you start that in your software development team if you don't have already one? Software security code review process can be intimidating, but hopefully by the end of this session, you'd be able to kick off your internal process. So why security code review process? Security code review process is known to be best at systematic approach to uncover security flaws. What does that mean? Other assessment methodologies to try to provide security assessments for applications depend a lot on the skills of the person doing the assessment, depends a lot on the tools being used, depends a lot on the time given, like for example, web application penetration testing. However, I'd like to believe that security code review process is a deterministic way of finding, of uncovering security flaws systematically. If you apply the same process over software, you get the same results. And this is what we care about in business. So I'd like to believe that security code review process is a way to take the magic out of finding security flaws and make it more like a process that can uncover security flaws systematically. Security code review is also good at covering close to 100 script that would look for that particular cross-site scripting pattern in the source code and find all the similar cross-site scripting issues, right? Versus, for example, web application penetration testing or other ways of testing applications where if you found one, you might not be able to find all the rest of the instances of the same vulnerability easily. And it's the only way to find certain types of vulnerabilities, like application logic bypass, like certain types of SQL injections, like certain types of cross-site scripting. This is only because we actually see the code. So, if security code reviews are that good, why not the software development, why the software development industry is not using such a great process? I like to percent of the source code. We can argue whether it does actually get to 100% code coverage, or do we even need 100% code coverage, right? But we can agree that we need to cover as much of the application, we need to test as much of the application as possible, and security code review is best at doing that. Better at finding design flaws than other assessment methodologies, other testing methodologies. And why is that? Because we have an aerial view of the application. You're looking from above at the application. So you're not constrained by a UI, you're not constrained by what the application is serving you because you don't care. You're looking at the source code itself. And this is my favorite. It finds all the instances of a certain vulnerability. So for example, if you found a cross-site scripting issue, for example, it would be really easy to like write